I will be live. It will show in a few moments. I had to start it manually.
Okay, just let us know.
Okay, yep.
Is it live?
Yeah.
Okay, it's live.
You can start. I will be muted. But oh shit, we still need uh, speakers. I forgot to drag it. Great. My bad, guys, my bad. Okay,
Oh, turn up the volume.
slideshow. Okay, is it live, guys? Is it live?
Bavia, it is live. People already can hear us.
Okay, is it live, guys? Is it live?
Bavia, it is live. People already can hear us.
Is it live, guys? Is it live?
Bavia, it is live. People already can hear us.
Live, guys? Is it live?
Bavia, it is live. People already can hear us.
Guys, is it live?
There is a loop.
It's on loop. Guys, is it live?
There is a loop.
It's on loop. Okay, guys, it's done now.
There is a loop.
It's on loop. Okay, guys, you can start. You can start now. I will just add speakers.
I'm
here.
sorry, but the recording it's repeating itself.
Really?
Okay, we gotta start.
I
Okay,
can't.
so Bambia, let me know if we can start, please.
You can start, but actually I cannot show the speakers. I don't know why.
It's all right. We'll do it this way. We have to do it.
Yeah.
Okay.
I'm sorry, guys.
It's all right. Okay, hi everyone. At first, I really want to apologize for us being late. We had some connection issues and we really had to settle them quickly. I'm really very, very sorry for this. So let me welcome you at Space Week webinar. We're excited to bring together industry experts to explore the wonders of astrophysics, astronomy, and their impact on our future. This event is part of a Space Week where we celebrate innovation, discovery, and the pivotal role of space exploration that plays in our lives. Before we dive into our amazing discussions, let me introduce our distinguished guest speakers and myself. First, we have Alexandros Iliadis, an astronomy and astrophysics expert who will cover interesting topics about exoplanets in our solar system. Then, we have Celine Hanna, an expert in aerospace, astronomy, and astrophysics, to share key concepts that help us understand the universe better, along with lessons from her own space-related experiences. Next, we are honored to have Mervyn Karanchi, a leader at RTX in aerospace technology, who will provide insights into breaking into aerospace and thriving in the field. And lastly, I'm Alica and I'm co-founder of young4STEM. I am passionate about biology, genetics, and I love to bring people together who share the same passion. Okay, so without further ado, let's get started with our first speaker. Our first speaker, Alexandros Iliadis, is an expert in astrophysics, and today he will introduce us to interesting facts about exoplanets and planets in our solar system. Alexandros, over to you.
So, first of all, I am really glad, and it's a pleasure for me to speak in front of you. And I'm actually not an expert, but I have studied a lot. So, and participated in astrophysics Olympiads. And I hope you like the presentation. So, I can't see my presentation.
First slide of your presentation.
I can't see anything. It's the presentation. I will do the presentation.
Can you see it now? Can you see it now?
Ah, yeah. Yeah, yeah.
Perfect.
Yeah. So, my name is Alexandros Iliadis. Today, I'm going to speak into. Okay, just let me introduce myself first. Okay. Um, as I said earlier, I have participated in many astrophysics Olympiads, and I have been awarded in one of them, like in the junior Olympiad. This year was in Brazil in the senior Olympiad. I didn't manage to take a medal or an honorable mention there, but still it was a very nice experience. So I am a student at the Krithikana Genesis in Greece, and I will graduate next year. I love playing tennis, and now let's move on to the presentation. That's okay. Okay, so today I will speak to you about solar system, and I want to give you a tour to our planets. So let's see. And in 3, 2, 1, let's go. So first of all, let's start with the definition. What is solar system? Solar system is a set, let's say, of 8 planets with their moons in orbit around the sun, together with smaller bodies like comets, asteroids, meteorites. So in this slide, I have given you a categorization of the planets. Previous slide, please. The previous. Uh, one more, previous. Yes, right. So have given you a categorization of planets. So we have Venus and Mercury as inner planets, which are closer to the sun, like than Earth, and we have outer planets which are like outer and in the greater distance from the Earth to the sun. So outer planets like Jupiter, Saturn, Uranus, and also Mars, while inner planets are Mercury and Venus. And moving on now. Next slide, please. So this slide gives you like a quick idea of how the atmosphere is in some in the planets. Like I have written the 3 main elements. For Mercury, we have oxygen, natrium, magnesium, and for Venus, we have carbon dioxide. It's like a greenhouse gas. So for Earth, we have like nitrogen, argon, and mainly for the outer planets, you have like hydrogen, helium, and methane. Methane, yeah. So the 4 planets, Mercury to Mars, are terrestrial, or to be terrestrial planets, because they have like a solid surface, while Jupiter, Saturn are gas giants. They don't have like a surface. So if you go there, I think, and yeah, you will just go down. You will just not touch the surface. Gone. Planets and dark planets. Dark planets are really tiny. They're smaller even than the moon, and they haven't been able to clear their orbits of debris. So this is why they're considered dark planets. So yeah, like we know Eris, Pluto, Haumea, Makemake, and Eris as some dark planets, but we consider to have more dark planets in our solar system. Moving on. Next slide, please. And now let's see something that really is really interesting. This hasn't to do with astrology so much because like my dad when he saw this like he told me like, do you do astrology now? So yeah, it's just like pure astrophysics. It's like sun has this symbol, Mercury, Venus, etc. Venus has this symbol called like the face and the helmet of it. Mars, this is the masculine symbol. Venus is the female symbol, etc. And Neptune will have the trident. And it's similar for the other planets. So if you want, I can give you this slide in the YouTube later. Now moving on to the planets. Let's see. This is a nice and interesting graph, I think. We have the planets like as fruits. So if Earth was a cherry tomato, then it would also be cherry tomato, Mercury would be peppercorn, Neptune would be a lime, Venus an apple, and of course Jupiter watermelon. Sun is not here because it's too big to fit in this. Moving on. So this is like a thermometer, and we can see the temperature of its planet. Venus like 470 Celsius. It's like the hottest planet. And Neptune is minus the minus scale, and it's the coldest planet. You can also see the other planets. Mars has a bit closer. The temperature of Mars is closer to Earth than any other planet. So yeah, but still not there. Okay, moving on. Next slide, please. Yeah. So here we can see the planets and their orbits, time of orbit. So Mercury is the fastest, and Neptune is the slowest. So I have given you like infographic here. Mercury saying, "I'm the fastest, hooray!" And Neptune saying like, "No, I am the slowest." So yeah, moving on. Next slide. But then Mercury comes there and says, "No, don't worry." One previous. No, don't worry. Yeah, maybe next time you can do it. And Neptune saying like, "I will try harder." So yeah, moving on. The end of the day, Venus has the biggest day, and the Fugak says like, this has been a long day, and like it's like 243 Earth days. It's even bigger than the year, than the duration of the year in Venus, and that's because it really rotates much slower around its axis than it rotates around the Sun. Moving on. Next slide. Nice. So let's about Mercury first of all, and some mythology about it. So why do we say Mercury in this way? Why do ancient people call it Mercury? So in Roman mythology, Mercury was the messenger of the gods and could fly really fast in order to deliver a message. It's, so since it could fly really fast, we thought, ancient thought to give him the name of the fastest god, fastest planet for the fastest god, so Mercury. Uh, yeah, moving on. And I just want to say that, like Mercury, Venus, and the other planets, we will see the Roman gods and not the Greek gods, because in Greece we have also our mythology. It's really known, I think, and I hope. So, like Mercury in Greek is called Hermes. It's like again the messenger of the gods, and Venus is like Aphrodite. Now, about Venus, Venus was the goddess of beauty and love, and planet Venus is a very bright uh, star, let's say, in the night sky. It's not a star, it appears like a star in the night sky, um, and therefore it's like the third brightest object in the night sky. We have Sun, Moon, and then Venus, and since it's the third brightest object, we call it Venus, who was the most beautiful, like, let's say, god. Moving on. So about Earth now. Earth does not have a name that comes from God. So, oops, I was not named after God. Yeah. So, the name was taken actually from the Anglo-Saxon word Erda, and Erda means the ground. It's like Erda, Earth. So, yeah. Mhm. Next slide. Mars. Okay, let's go to Mars. Mars was named by the Romans for their god of war because its reddish color was reminiscent of blood. Therefore, war, therefore Mars. The Egyptians, as a fun fact, we can say that Egyptians called it Her Desert. I don't know if I pronounce it like well, Her Desert, I don't know. I don't know their language, but this means the red one. So we have an image of Mars. And moving on. Jupiter. So let's see Jupiter. Jupiter was like the father of the gods and was the strongest god. And since planet Jupiter is the biggest planet, Romans named it in this way. Uh, I think you really didn't want to fight against Jupiter. He was like the strongest one. So yeah, that's how Jupiter got his name. His name. Moving on. Galileo Galilei now, in like 17th century, when he was seeing through his telescope, he saw four satellites around Jupiter. So this was something that really supported the heliocentric system, and because didn't not everybody in the solar system rotated around Earth. So as Galileo proved, we have the satellites of the Jupiter. So these four satellites, four moons, are considered nowadays to be like the most fascinating destinations in our solar system. And we're going to see some photos of them in the bottom at the bottom of the page. Moving on. So Saturn is like if you take Saturn first of all, just to mention this as a fun fact. If you take Saturn and you throw it like a stone in the sea, it will go down. It will not float, and this is because of its really low density. Saturn was named after the Roman god of time because it was the slowest planet of the bright ones that were known in ancient times. Ancient people knew till Saturn. They didn't know about Uranus or Neptune. Uranus, as we will see in the next slide, is what happened? Uh, is like Uranus was discovered in 1781 by William Herschel. I don't know, I cannot see the presentation. What happened? Am I talking alone? Am I alone? Oh, what happened? Can you hear me? Yeah, hold on. Uh, so Herschel wanted to call his planet the Georgian Cedar as a tribute to King George III of England. He was the king at that time. Johann Bode, however, suggested a name that would be in conformity with the other planets' names. Um, so Uranus, who was like the Greek god of the heavens. And I was talking about how Uranus was discovered. So William Herschel, was looking through his telescope uh, and saw this planet. He was then with his sister on that night of observation. When he actually saw Uranus for the first time, he thought it was like a comet, not a planet. But after a lot of days of observation, he finally realized that it was a planet. And fun fact about Herschel, he was a composer and not an astronomer in the beginning. But the passion he had for astronomy really made him to buy a telescope. So, we go to the last planet, Neptune, who was actually discovered by mathematics and mathematics in the change in the orbit of Uranus. Um, so it was just like first they found it with mathematics and then they observed it. So shortly after its discovery, Neptune was only referred to as the planet exterior to Uranus or as Leverrier's planet. If I was Neptune, if I were Neptune, I wouldn't like really the name planet exterior to Uranus. I would feel like really below the others. But then Galen proposed the name Ianus, and there was another proposal, Okeanos. At the end of the day, Leverrier, who discovered the planet, claimed the right to name his discovery, and he named it Neptune, so from the Roman god of sea. So now we have all the planets, 8 planets, named after a god. Uh, and Pluto, who is not a planet but a nanoplanet, dark planet, was also named after a god. But this is a whole other story. And now I would like to close with a thought that, like, we were we may be the first kind that walked the earth and just had and get to learn those things about planets. Like dinosaurs didn't know about it, or fish or anything else before us didn't have this knowledge. We were the first kind that walked on the earth and had this knowledge. So thank you. I won't tire you anymore. Thank you very much.
Thank you, Alexandros. Our participants have prepared also some questions for you. So the first question is, what challenges may international students face when studying astrophysics or astronomy?
Okay, just a second. I think that Celine had to go somewhere at 6 or had a job to do. If this still on, can we do the questions after Celine? If this is possible?
Yeah, okay. And there's also one really personal question about what would a person who is interested in astronomy, physics, astrophysics, would recommend to do in high school. Someone like you who is already in high school, interested in astrophysics, astronomy, what would you recommend to someone aspiring as you are?
Oh, okay, so I will answer these questions. Okay, what was the first question before I move on to the second one? Yeah. Okay, what would I recommend? Okay, I will answer just this. Sorry for that. I would recommend that he like get out and study astronomy and follow his passion and live the life he wants to live and not be scared at all. And also just try to participate in competitions, national or universal national competitions. In many countries, they have like great programs in school. They learn it is astronomy a lot. So yeah, I didn't have this chance, but other countries and other students in other countries have this chance to do. So yeah, just follow their passion.
Okay, thank you very much. Thank you again. So thank you, Alexander. So moving out to our next speaker, our second speaker is Celine Hanna, an expert in aerospace, astronomy, and astrophysics. And today she will introduce us to key concepts that help us unlock mysteries in the universe and share valuable lessons. And Celine, it's over to you.
Hello, everyone.
Hello.
Start screen. I can see it. So, hello, I'm Celine, aerospace engineering student and physics student, University of Bayman and Lebanese University. Let me start by, in this challenging time, let me start speaking from my heart about a place, my country, with shine even in the face of hardship. This type of the trail of war, we still shine. We are a dreamer who once dared to reach the star with the rocket science society, and we continue to dream today. And nothing has stopped me today for being here with you for World Space Week, sharing my passion for exploration. And we will keep reaching the star no matter how dark the time may be. So Lebanon is here shining brightly. Let me start to talk about some experience and the reason why I chose aerospace and astronomy. Since I was child, I love space, astronomy, and astrophysics. So I chose aerospace and physics. as a major, I created a astronomy club at my university. So I become a lecturer and instructor and business developer at the Cosmic Dome company. It's a company for space and astronomy. We do event and lecture. Some of my experience that I did internship at Lebanese Air Force with helicopters and military planes. So it was one of the hardest internship. Also, I participate at NASA Space App Challenge for the first time in Lebanon with two projects related to space and aerospace, which I created a deployable system for Mars for Neutron mission. The next slide, please. I'm gonna start talking about one of the most mysterious forces out there, and this is the law of gravity. To understand space and astronomy, let's start with the most mysterious force. Gravity has played a navigating role in the biology of the human body. In fact, life as we know it will not have exist without the force of gravity. Also, it governs our everyday lives. The 100 billion members of our human species that have ever lived have struggled to understand its nature. In the 1900s, and at the age of 26, Albert Einstein was working and thinking about the universe, about everything that surrounds us. And his idea has contradicted Einstein, Newton ideas. So he had to come up with new models. He had to come up with new theories. So according to Einstein theories, the fastest thing there in the universe is light. And light moves at the speed of 300 kilometers per hour. And for Einstein, nothing ever in the universe can exist that fast. Now we know that the sun is at the distance of 150 million kilometers. So from Earth, so every single light, every single protons you receive from the sun on Earth has an actual escape 8 minutes ago from the surface of the sun, and according to his theory, but Newton has a different theory when it's come to gravity, and for him gravity is a constant force. We all know that we have the sun, we have the planet Earth, and the planet Earth is orbiting around the sun. Let's see what's gonna happen if the sun vanish. So according to Newton, if the sun disappears for whatever reason, the Earth and the planet, and that the force of gravity will become zero instantly to a moment in no time, and such of the Earth will be moving along straight line. But again, if we go back to Einstein, what he said, that the speed of light acts as a cosmic light. So if gravity moves instantly, then it's faster than the light, and that's a great contradiction between the two ideas. So Einstein, he tries to measure the speed, the rate at which gravity moves, and when he did that, he found that the gravity moved exactly at the speed of light. And can you, the next slide? Oh no. So it will take 8 minutes to the Earth to feel the distance from the sun. In order to talk further about Einstein theories about gravity and about light, we have to talk about dimension. Any point on Earth can be located in 3 dimensions, the X, Y, and Z dimension. But I can move forward and I can move backward, right and left, up and down, and there are 3 different dimensions that can be moved on. But concerning for the following fact, you have never met someone at a place unless it was at a time, and you have never met someone at a time unless it was at a place. So if I wanted to invite someone to this meeting, I have to tell him the time, and that's that 3 dimension. Well, that time should meet should meet with them. And what he did, he fused the three dimension of space, X, Y, and Z, with one dimension of time, and he fused them, and it will become a four dimension of time. So his idea changed our understanding of the universe and for the nature that around us. So let me show you, no, not this slide, one before and one before. Let me show you what I mean exactly by space-time. We have here the Earth, the Moon orbiting around it. Without it appears it's straight and flat because there is no matter on it. So if we take a sphere, it has a specific mass, and if we place it, we take a sphere and bend it due to the existence of matter on it. Assuming this Earth and a little sphere, this is a moon, and the moon has a such less mass than the Earth. And if I present the moon in the vicinity of Earth, the moon will be orbiting around the Earth because it has a locate and the value that Earth has created due to the existence of its mass, because the moon is orbiting around the Earth because it has a locket in the value of the space-time that Earth has embedded on the fabric of the space-time. So this is the idea according to the gravity. Please, the next slide. Now I'm gonna start talking one of the amazing thing of the sky is the sun. If our sun is a star, then all the stars in the night sky might be the sun of someone. So sky might be the sun. So all the atoms in our body were once created inside the core of the massive star. In the beginning, when the universe was created, there was only hydrogen and helium, and all the heavier elements like carbon, nitrogen, oxygen, iron, and all the elements in our body were once created inside the core of a massive star during the process of nuclear fusion. And in 1924, Edwin Hubble announced that the universe was full of 100 billion of galaxies, and each galaxy have 100 billion of stars orbiting around it. And let me talk about why do stars shine? It's the nuclear fusion. It's the kind of the combination of two nucleus. If you have two nucleus and you break them together, this is when you do nuclear fusion. And if you have you have to think about nucleus, you have to think about the hydrogen atom. That is the simplest element we have in the universe. Hydrogen was the first element that was created after the Big Bang. And think about the water we drink, H2O. If I try to bring them together because they have the same charges, these two nucleus try to repel each other. And think about also protons. If you bring two positive charges, it will make the touch, it will repel each other. And if you are able to bring two hydrogen atoms and make it really fuse and combine, so it will be one entity, and so create so much energy, and this energy will be last for a long time. So here is a little map for the creation of the stars. Stars are born from cloud of gases. They collapse under gravity and they become a protostar, a baby star. If the star is not very massive, it will become like our sun. It will fuse hydrogen to helium for a billion of years. And when it has no more hydrogen to fuse, it will become a red giant, and it will fuse helium to carbon. When it has no more helium to fuse, it will become a nebula. So it will throw the gases away, and it will become a white wolf. Another scenario is the following. If you follow me in the next step of the picture, if the star born with a very massive structure, when it has no more hydrogen to fuse, it will become a supergiant, not only a giant, and the supergiant fusing helium to carbon, and then it will be explode. And when it explode, it will be very massive. It will become a black hole, or it will be a little less massive, and it will be a neutron star. And now we see the picture of the black hole. And also, just a picture was probably the universe, not all of them, but we can see the quantum, the inflation, the dark ages, the development of galaxies, planets, and the dark energy acceleration. And no, if I'm gonna talk about aerospace engineering and astronomy, aerospace engineering play a crucial role in astronomy by developing the tool of technologies needed for space exploration and observation. And this include satellite, space telescope, and spacecrafts that allow us to study distant celestial bodies. So engineers creates launch vehicle to carry this instrument into space and ensure reliable communication to transmit data back to Earth. So by providing technologies for human advanced navigation system and testing equipment for space environment, and also developing technologies for human space mission, aerospace engineering is a fundamental in advancing our understanding of the universe. As we can see, the Hubble Space Telescope, James Space Telescope, and it's also, I can see, it's a habitat for and life support system. So for human space exploration, develop spacecraft and life support systems that allow the astronaut, let's see, to live and work in space. And also it's a simulation, environment simulation, as I can see. It's testing astronomical instrument and spacecraft can operate effectively in space, contributing the success of astronomy missions. So for example, celestial mechanics and the guidance algorithms for astronomical observation and satellite.
Okay, thank you so much, Celine. And I have also prepared some questions for you. So the first question would be, is the space silent? And if so, why?
Yes, space is silent because there is no medium like air to carry the sound wave. Sounds need a medium to travel, and since space is a vacuum, there is no way for sound wave to propagate. So yes, space is silent.
Thank you. And I have another question for you. And it has been hypothesized that the space is expanding. So how does the expansion of the universe make outer space a vacuum?
The expansion of the universe means that galaxies are moving away from each other over time. So increasing the distance between them. So space is already a vacuum, meaning it contains a very few particles. As the universe expands, the space between galaxies become less dense, which simply means that they have already sparse particles are spread out of a large area. And this expansion doesn't change the fundamental nature of space being a vacuum, but increases the separation between existing matter.
Okay, wow. Thank you so much. And lastly, we have a question from comments, and it says, what is the difference between black holes and neutron stars?
Yes, as I said before, in the formation of star map, when it's formed a nebula, it will separate in three ways. One, it's a low mass star, become a sun red giant, a nebula, and the white dwarf. And another scenario in the picture, we can see a high mass and red supergiant, and this supergiant become a supernova, and the supernova will divide into two, one the black hole and one the neutron star. The question is the difference between a black hole and what?
A neutrino star.
Oh, okay. When it's explored and it has a very massive, it will become a black hole. When it has a little, it will become a neutron star.
Okay, thank you so much, Celine. And
Do you
our
want?
next speaker. Okay, and so our next speaker is Nurivin Karanchi, a leader at RTX and one of the top aerospace technology companies. Nurivin will share her journey into the aerospace industry, offering advice on how to break in and excel. She'll also discuss what it means to be a leader in this field. So, Mervin, please take it away.
Hello, can you hear me?
Yes, we can.
Okay, great. I just wanted to make sure. I'm so excited to be here. I have enjoyed the presentation. Celine and Alex, I think you both did a phenomenal job. So I will pivot and give a little bit of a different presentation from them. I know Celine talked a lot of the technical details. So I'll just be giving advice to students on, how to actually get into the industry and start working and how to excel in that aspect. Next slide, please. Okay, so as I was introduced, my name is Merivin Karanche. I'm glad to be presenting to you all today. So a little bit about my personal background. I was actually born and raised in Kenya. As you can see on the location tag, that's on the east coast of Africa. And I moved to the US at 17 years old. So that was a little bit of a culture difference, but we made it work. So I completed my high school career here, just doing 1 year. And my hobbies include flying airplanes. I love that this is a space where everybody loves like aerospace or astrophysics and all that stuff. So I've always wanted to work with airplanes as far back as I could remember. So I am currently a student pilot, and hopefully soon enough I'll have my license and I'll be flying around. I enjoy basketball games too, and I love traveling. So I've lived on the East Coast of the US. I moved to the Midwest for work, as you can see in the middle of the US there. And right now I'm on the West Coast. And in 3 weeks, I'll actually be heading to the South in a state called Alabama for a new job position. And for education, I went to Rutgers University. I do have a bachelor degree in aerospace engineering. So it's a tough field. Celine, props to you, but you'll make it through. And it was tough, but I graduated with highest honors because I put the time in. And I'll jump into the roles I've held till date. So it's still the previous slide. So I got an internship opportunity in my third year of college, and I was a lead project engineer supporting B747 engines. So those are known as PW4000 engines at Pratt & Whitney. It was exciting. It was an exciting role because For those who know more about the commercial field, like the 747 is the queen of the skies, and arguably one of the most revolutionary commercial airplanes to date. So for me to work and lead a project on that, I think was groundbreaking. I worked on C-17 engines too. They're known as F-119 engines at Pratt & Whitney, massive, massive aircrafts. And I think they have the best mission because they provide humanitarian aid, and that hits close to home for me. So I stayed at Pratt & Whitney as a co-op for a year, and I worked part-time, went to school full-time. If anyone has questions on that, please feel free to reach out to me. I can give you a little bit of advice on that. So overall, great learning experience. After completing my co-op, I accepted a position at RTX as an associate in the leadership development program. I'll talk about those a little bit later on in my presentation. So I really wanted to understand the industry as a whole. That's why I think that program, I'm still in it. It's a great way to do that. My first role, I had visibility to like the end-to-end procurement process. So usually the engineer creates the drawing, and then we send that drawing to a supplier who actually makes the parts, and then they send the parts back to us. So we assemble the product, and then we ship it to the final customer, who could be Boeing most of the time. And after that role, I pivoted back into engineering. So right now I'm in a manufacturing engineering role. I'm located in Los Angeles, California. And this is a wheels and brakes business. So we support wheels and brakes for like most of the West Coast airports and airlines. We go a little bit into Mexico too. And lastly, I just want to say I'm in a field that I love, and every day is an adventure. So I'm happy that I get to live my favorite quote, which is, if you do what you love, you will never work a day in your life. So for those interested in aerospace, please keep within this field and you'll love working. Next slide, please. Okay, so I just wanted to touch a little bit on my biggest takeaways from engineering school. I have 5 points here. So one, I would say you get out what you put in. This was a lesson for me because when I first started school, high school was easy for me. So when I got into engineering school, I thought it'd be the same thing, but it's actually not. So you actually have to put in time, attend professor office hours. That was very key to my success. And I would say study groups, or even if self-studying is the best method for you, I would say go that way, but just make sure you put in time because you will get what you put in. And then 2, I say join clubs and their leadership teams, because the industry is a lot more than just being good in school. You need to know how to work with people. So the clubs could be, they could be actual like robotics club, it still ties into aerospace or into like the STEM field, but it could be other clubs, like you could be into modeling or something like that's sparking your creative energy, and that still helps you school-wise. And also I put leadership teams there because it's great to learn leadership from a younger age, because we all want to be leaders someday. We're leaders of self, and probably in the future we'll be leaders of people. So start pursuing those opportunities earlier on. 3, I'd say network and hopefully complete a co-op or an internship or a study abroad opportunity, just because that does play a part in your success in the industry, and networking goes a long way. I know a lot of people who just place applications online. I would say actually find a recruiter and talk to them, because that one-on-one is what makes them have faith in you or actually understand what you've done and what you're capable of doing. 4, I'd say it's okay to not have it all figured out. This is something that I saw a lot of my friends deal with. Even if you're in a field and you feel like maybe you have too many interests, or you just don't see yourself in a particular space, it's okay. A lot of people feel that way. My advice is, go out, try different things, because one thing will click. You know, the more you try, the more you're gonna find your foot and, you know, see where you would actually excel. And then 5, always believe in yourself. That is crucial. It's key because confidence will take you a long way. And you know, sometimes times are tough, especially engineering STEM field. It's hard. You know, it's not, what we learn is not easy. But if you believe in yourself, you know, even if you don't do well one time, you'll give yourself grace to be able to excel the next time you try the same thing. And at the bottom, I decided to add this because I feel like a lot of people focus on technical skills, but you know, technical skills get you in the door. You know, they get you that first job, but soft skills will take you 1,000 miles. The soft skills that you get, you know, that could be teamwork, accountability, like trust, respect, stuff like that is what actually makes people want to work with you. You know, it makes your leaders feel like, oh, you're promotion worthy material because you work so well with people, you communicate so well. So from a younger age, I would say emphasize on doing both the technical and the soft skill part. Next slide, please. Okay, so a little bit about RTX. RTX is the world's largest aerospace and defense company. It's where I work. I absolutely love this company. I just think it's important if I pitch it here because as much as I'm from the US, I know people from the call here are from across the globe. And you can see like all those pins, those are where we have locations. We have sites across the world. Like there's a plethora of them in the US. You see a lot of them in like the Europe area, Asia, like Middle East. I put Australia there too. Like we have sites across the world. And that's really important when you start a career because a lot of times you just don't want to live in one place for the rest of your life, you know, but if you're in a company that has sites across the world, you can use that opportunity and, you know, you move jobs, but you don't leave the company. So you're still within the company and you're pursuing new adventures every other time. Next slide, please. Okay, so RTX, I'll talk about our 3 different businesses. So RTX is the parent company, and it's a merger of 3 companies. So we have Collins Aerospace, Pratt & Whitney, both of which I've worked in, and then Raytheon. So Collins Aerospace has different sub business units. First picture there, you see an engine, but the engine is not the product there. It's the outer cover. It's called the nacelle. So the front, you see the inlet portion, and then the back structure that kind of looks like wings is a fan cowl. So we do make those products. And then to the right of that, we see the interior portion of the aircraft. We have a hand in that business too. And then bottom left, you see the cockpit. So we actually own a lot of the avionics portion for airplanes. So the instrumentals that pilots use, we have a hand in that. We make the helmet for those who know the F-35 fighter jet, which is like the coolest plane. We make the helmet for that. So there's engineering opportunities there or just STEM opportunities. You know, computer science, there's a lot of programming that goes into designing the cockpit for the pilot. And then at the bottom right, that is the wheel, brake, and the heat sink part of the aircraft. And that is the business that I am currently in and supporting. So just great things. Pratt & Whitney, which I worked, like I said, for a year. We make the engines. We have legacy programs. We have a lot of engines. We even have the F-35, which is, I think, one of our latest contracts that we fought really hard to get. So great things there. And then side. So, you know, if you're into the military stuff, like that's where we make the missiles and so we send actually satellites to space. So that's more on the astronautical part of it. Next slide, please. So for the last slide, I just thought that I'll highlight my favorite career opportunity that I'm currently thriving in. But first, I just want to say that there is a variety of careers in the aerospace industry. Like you don't have to do an aerospace engineering degree to get into this industry. As long as you have a STEM degree, there is a place for you. So like I said, reach out. If you want my email, I'll send it out. and I'll just kind of have those conversations with my network and, try to get people opportunities, because I think that's the beauty of why we hold these calls and why we have these conversations. So I will talk about rotation programs. So a rotation program is a program that lets the candidate pursue 3 roles in 2 years, usually. They're a little bit different, but most of them, it's 3 roles in 2 years. For my company, there's 3 major ones. So one is department rotation roles. What does this mean? It means that you'll rotate within a department. So let's say the department has design engineers, structural engineers, project engineers, a little bit of tooling. Like you get to do three or it could be like out of 5, 6 roles, but you get to pick 3 of them. It's an 8-month role. So you do 3 8-month roles, and in 2 years, you kind of finish the program and then you pick what role you like best. And I think this is really important because you get to understand what other people do when you're supporting them. Let's say you off place as project engineer and you did like design and structural engineers and you work with those people every day. Like you will know what they do, and a lot of times you might even know what to do before they even ask you to do it. So that's the value that you get from it. Second one is Collins Aerospace Rotational Programs. So those are primarily engineering roles, but they have a lot of STEM people. I believe they should have STEM people in them too. So this is a little bit of a wider scope. So instead of just doing 3 different roles, you get to do 3 different roles in 3 different locations. So, you could travel, you could be on the East Coast for one role and then move to the West Coast for the next role. It just gives you that traveling opportunity. And then third, but obviously not least, is the RTX Leadership Development Program, which is the widest scope. So you get to do roles, 3 different roles in 3 different locations, and possibly 3 different businesses. So like I said, we have Pratt & Whitney, Collins Aerospace, and Raytheon. So I could do a role in Pratt & Whitney today, and then tomorrow I could switch and do a role in Raytheon. So I'm trying different roles in different locations. I'm getting to actually see how the entire business comes together. But yes, that is all I had planned for today, and I'll welcome any questions.
Thank you, Mervyn. Again, it was really amazing presentation, and I think really many people enjoyed it. So the first question I have, thank you. So the first question I have is, if you could change a few choices that you made during your youth in terms of career and university, what would it be, or what is the #1 advice you would give someone starting university?
Well, that's a loaded question. If I could change something, okay, I would say, first of all, let me answer the advice and then I'll answer the change question. So advice, I would say check your work ethic. Because I know a lot of people are really smart in high school, and I don't doubt that one bit. But when you get into college, it's a different playing field. So like when you join, just have that mindset that you have to put in the work. And like I said, it was one of my slides. You just have to approach it as, something that you want to do really well in. But even if you don't approach it the first semester, this is so common in the in college. Like people always do so bad in their first semesters, but then, they realize that. But if you come in knowing that it's not easy, then you get to actually not have to experience that bad portion of it. So come in ready to work, and you'll do great. And for what I would change, I would say I tend to analyze things a lot. I found that it has a term, it's called analysis paralysis. It's like when you want something to be so perfect that you spend ridiculous amount of time on it that you didn't even have to do that in the first place. So for me, I've it's first step is being aware of what you do and then trying to find a way to counter that so you don't do that anymore. For me, it's been having people hold me accountable, or I put a time frame and I'm like, okay, if I have this project, I need to get it done by this time. I can't extend it one day just so I can analyze it a little bit more and see, what could be wrong. So it doesn't have to be 100% perfect, but it also comes with trusting yourself. If you do something and you feel like, okay, I did it to the best of my ability, like go ahead and send that project in. Don't spend 3 days on something that you only needed to spend a day on, but yeah.
Thank you so much. This was a great answer. And another question is, how do you think the landscape for women in space exploration has changed over the years? And what are the needs that what needs to be done to foster diversity?
Okay. I think the landscape has pivoted in a very positive direction. I say that because, I see how my company, because I can speak for RTX, but I'm pretty sure this is across the industry. Like they put a lot of emphasis on, hiring talent that is from a diverse skill set. And this goes back to the past. Like in the past, they were maybe going to certain schools and like leaving other schools, but there's excellent students in every school. So if you go to a school that's more diverse and pick up excellent students, you're actually helping the industry because everyone is so unique, and it's the uniqueness that makes us have such great products. Because if we all think the same thing, the same way, we're probably going to make the same thing, But if you think different, I think different, everyone else is from a different culture, different background. They will actually make the best product. It's called, like, it's part of innovation. So I think it's pivoted in the right direction from what I've observed. What I think we can do to make it better, I would say, so I feel like we don't start inspiring our younger, like our more diverse group from a younger age. Because I felt the push when I was in college. I saw all these recruiters come up and, talk to me. I saw it in the workplace. They do a great job making sure, like, even when you're in the company, you feel welcome and you feel like you belong in that space, because they educate your fellow coworkers and they're like, oh, if we have ladies on the team, you don't say certain things, like you actually foster an environment where everyone is comfortable. But I feel like we don't do that a lot in high schools, because I felt like the D&I is really great in colleges and the workplace, but not as much in high school. But that could also be upon high school students. Like if you feel like you see a great opportunity, like talk to your teachers, let them know that, you see something great that another school is doing, and then they can implement that too. But yeah, I feel like I can talk on and on for days because I'm really passionate about stuff like this. But it's been really great being a part of this session. Thank you all for having me.
Yes, thank you so much, Marvin. And I have got very last question for you,
Okay,
and
okay.
it's from the comments.
Okay.
And it says this person wants to pursue engineering and is interested in engineering research. And what should he focus on during during his high school studies? If you have got some more tips, and yeah, how could he start, or she?
Okay. Well, I didn't do a lot of research. It's kind of why I'm a little hesitant to answer this one. But I would say it's always good to know people who can answer your questions the best way. Like I wish I could give more insight, but I'm pretty sure within your school there's teachers that are more versed in, like, research opportunities. But I do know in college, if you go to college, there is a lot of opportunities. Like for my school at Rutgers, there was a lot of research opportunities. Different professors have that. So when you do go into college, I would say make sure you pursue that. Just right off the bat, build that relationship with your professor and let them know that you're interested in that. But for sure, if you're in college, you'll have a lot of opportunities in that realm. In high school, I would say talk to your teachers. Find different teachers and, see their opinions on what's available in your school currently.
Okay, thank you. I think this was a great piece of advice. And okay, so I want to thank all speakers. I want to thank you, Alexandros, Celine, and Mervin, for these incredible presentations and the knowledge you shared. And I want to thank also everyone for joining us today. And special thank you goes again to our amazing speakers, and we hope you found today's discussions amazing and also insightful. And before we close, I want to remind you to stay tuned for more exciting Space Week events and content. And feel free to connect with our speakers and each other after the webinar. And have a wonderful day. And thank you again for joining us.